We're going to start this puppy up. Clear, prop.
And welcome back to Tip of the Week. This week we're going to start a series on building the Sonex tail kit. That's the horizontal vertical stabilizer, the elevator, and rudder. This will be a 10-part series, step by step, so that you can see exactly how that kit goes together. The first half of this video installment will be discussing the tool requirements and kit building techniques needed for the Sonex aircraft kit. If you're an experienced builder and want to skip directly to the actual build, the build begins at approximately 17.5 minutes into the video, so you can skip ahead if you so desire. Our efforts are not endorsed or authorized by the Sonex factory. We are an independent company. The Sonex tail kit arrived on a small pallet comprised of just 4 boxes. The tall, thin box contained the skins neatly folded up. Here is a view of each and every part of the tail kit laid out on a table. At the back center are the 3 skins, 2 for the horizontal stabilizer and 1 for the rudder. And then below them are the many ribs of various sizes. And one of the most important documents at this stage is our inventory checklist. We need to identify and check for each part. Here's another view of the ribs. Note the many pre-drilled holes, which will make our job as a builder quite easy. And the same with the skins. Note all of the pre-drilled holes to match up with the spars. Throughout the build of the Sonex tail, we will be referring to drill bit sizes for making our holes and using clecos, which are temporary fasteners to hold our components together. Many of the pre-drilled holes in our kit are of the size 3/32, which is this size here. That's also very close to a size 40 drill bit. And holes of that size can be held together with a silver cleco. When it comes time to actually install rivets, and here are 3 of the most popular sizes, they all require a hole a bit bigger, and that size of a hole is going to be 1/8 or very close to a size 30 drill bit. A size 30 drill bit is slightly larger than 1/8 of an inch and makes the use of inserting rivets a little bit easier. A copper-colored cleco is used for holes of this size. It's very important to use the correct rivet size, as these rivets have different grip lengths depending how thick the material is, and there are also some rivets made for countersunk holes. In your plans, it will always specify the size of rivet to use. Before we can assemble our metal parts, we need to make sure that all of the edges are nice and smooth. In fact, our plans will often call for us to deburr our parts before assembling, and that's exactly what we're talking about here. When these parts are created, they're often sheared off of a much larger piece of metal stock, and that shear blade will leave the edges somewhat jagged and not smooth. There might be some sharpness, there might be some tiny ridges, and it's our job to make sure that all of these have been either filed, smoothed, or I'll show you a quicker way to do that rather than spending all the labor in filing all of the edges. The reason we need to do that is more than just making the part look nice or preventing us from cutting our fingers on it. A sharp edge is a good place for a crack to begin due to all the vibration in your aircraft and metal fatigue and bending. A smooth edge makes it much more difficult for a crack to begin. So there's certainly a structural reason why we want all of our edges nice and smooth. And this goes for pieces like this channel or an extrusion that either the factory cuts or that you cut. It's kind of hard to see, but there's a definite roughness after the blade or shear blade or hacksaw has cut these, so we need to clean all of these up. When it shines smooth, we know we've got it to the place where we want it to be. Even thinner metal pieces like this L angle need to have their edges gone over once to make sure they're smooth. And even skins, the edges of skins will show need to be cleaned up. Here's a part that you can possibly see where the edges have those tiny marks on them, and this needs to be very, very shiny and smooth all the way around. So although we won't show this repeatedly throughout our build process, we're going to make the assumption that you have cleaned up all of the edges on all of the parts before riveting them in place on your aircraft. Now let's take a look at two different ways to accomplish this task of smoothing edges. Now here's the slower way of doing it. Using a file, such as the one I have here, and then manually smoothing off the edge until we get it to the point where we have removed all of the sharpness. If you want to save a lot of time and have great looking aluminum components as you're building your aircraft, my recommendation is to remove the grinding wheel from your bench grinder and replace it with a Scotch-Brite wheel. This is made by 3M and it's available at all of your popular aircraft supply stores. And simply install it on your bench grinder. What we're going to do is simply run the part across the wheel at a 90-degree angle. We don't want to go this way or we'll cut a groove into the wheel as someone did on this one. But basically we're just going to go across all the way around both sides on the edges, and that will accomplish it very quickly and very nicely. Let's take a look here. Might be some noise. And we are done with this piece. That represents a lot of manual filing with our file, and the edges are very nice. And we can spend more time and use more pressure if we want, especially with a larger piece, but that's all it takes to clean this up nicely and have it ready for assembly. Here's another example, and I'll do a short section here so you can see the difference. This is the part the way it came from the factory after the metal shear chomped it off. It's a nice thick piece. I'm going to go ahead and use the Scotch-Brite wheel and show you how nice and shiny that becomes right in front of your eyes. This wheel was made exactly for the purpose that we're showing here. In addition to the edges being deburred or smoothed, any hole that we drill, or even the ones that the factory has punched, need to be deburred. Now what we mean by that is a lot of these holes have a tiny burr or ridge around the top that's sticking up from the top of the metal. And the problem with that is when another part or skin attaches to the holes, and you rivet it obviously, that burr will hold the part or the skin away from the surface. Even though it's a tiny amount, that makes a big difference in the strength of the assembly when the parts can't be held tight together. So we need to make sure it is perfectly flat by removing any burrs in these holes. Now it's a simple process, an important process, but a simple one. And one way to do it is to take a oversized drill bit, one that is much larger than the size of the hole itself, and simply press it in and twist it for about a revolution or two. That's it. What that will do is cut off any burr material from the surface. Now you don't want to keep going around and around and around and around, because that would countersink the hole. We definitely don't want to do that. All we're trying to do is remove any slight ridges that are on top of the surface of the hole. Now if you use a drill bit a lot, it's going to end up kind of cutting your hand, so you can wrap some tape around it. Rather, what a lot of builders use is a tool that looks like this. And this is available from your favorite aviation supply company. It has a swivel, and at the end is a cutter. This is used for countersinking. Now we don't want to countersink our holes, so you want to be careful with this and only rotate it once or twice, something like this. That's all you need, with just some very light to moderate pressure, and that will remove. And that way it just makes it a little easier when you have lots and lots of holes, rather than using the drill bit going through all of them. So every hole, whether it's on a piece of skin or a thick piece of metal, every hole needs to be deburred. It doesn't take long. You want to do that after the hole has been drilled to its final size. Another way to deburr, which is even faster, is to use a piece of a file. I took a file and broke it off in a vise, which is kind of an interesting operation in itself. And with this type of metals, which is 6061 T6, it is not plated. It is the same consistency, same type of metal throughout. And you can simply take it and run it across like that, and that will knock off any burrs. This is especially useful for inside, where it's hard to get one of these other tools. And I simply do something like this, rubbing it across, and that will remove the burrs. We're going to do this as our last step prior to assembling the parts and riveting. So it's very common to assemble the parts, drill them out together, and then take them apart so that we can deburr all the parts and then put them back together and then rivet. There are a number of clamps you'll see us use. These are pretty popular. They're adjustable here, and then you can clamp them down. Once we've finished up on the Scotch-Brite wheel or with the hand file, what I like to do is put a final polishing on there, and that's easily done with an inexpensive pneumatic die grinder. And on the end is another Scotch-Brite product. This is a Scotch-Brite pad. It unscrews very quickly. It basically has this holder, and these come in different grades. There's a red one, a blue one, I think there's another color. I just use the red ones, and they quickly attach by screwing on. And then because of the high speed in the pad, it's nice to go over all of the edges. Now this makes a whole bunch of noise, and of course it needs an air compressor, but by going over all of the edges you give it a final polishing and can make it nice and bright. Very nice for any aluminum that you want to polish up quickly. Not as aggressive as the Scotch-Brite wheel, but this does a very nice finishing job, and also nice for some tight or hard to get to places. They also make Scotch-Brite wheels in these smaller diameters. This one is pretty worn, but this can also fit into your die grinder, and that can be useful for getting into places like this with a very high RPM. That will make this nice and smooth in no time at all. Another method for deburring the edge of a skin, instead of using a file, is to use a tool like this. Notice it has a V notch in the end of it, and you basically drag this along the edge, and that will break off any burrs, and it goes something like this. You just stick it on the edge and pull, and here's another edge. You can sometimes see the filings peel off. You can do it once or twice, but that basically leaves a much more duller edge, and that's available at your local aviation supply store. Now you can certainly use your flat file and take care of this. It's just a little quicker to use this tool. Take your file and run it over the edge. Now we will prepare our T1303 drive horn. Now first we have already prepared our edges so they're nice and shiny, and got rid of all of the teeth mark using our Scotch-Brite wheel. Then we want to open up all of the holes with our 3/32 drill. So these are just pilot holes at this time. Don't need to deburr them because we'll be drilling them up to a larger size later. We need to identify the top as per our plans, and then we're going to make a line where we want to place a bend. This is going to be a very gentle bend. In fact, looking at the plans, we're going to raise this off the surface of the table just about 5/16 of an inch, so not very much. But we want a 1/2 inch radius bend here. So I'm going to take this over to our press, use a 1 inch cylinder to press down so that we don't get a sharp bend here. We get a 1/2 inch radius bend, but again it's a very small bend, and we'll know that we've reached it when we have lifted this corner right here off the table by approximately 5/16 of an inch. Now use your plans for the exact measurements. So let's take this over to the press. I have my press sitting here, 2 blocks of wood with a gap in between. I'm going to line up my line right in the center, and remember we want a 1/2 inch radius on this bend, so I'm going to use a socket that's approximately 1 inch in diameter, and that will give us our 1/2 inch radius. Now remember, this is a very minor bend, so I'm not going to go very far, but I'm going to line this up on the center, and then crank it down just a little bit, and my goal is to have this tip raise up approximately 5/16 of an inch. So I want to make sure I don't go too far. But that's all I'm going to do, is end up pumping the cylinder down and bending it. Now it's hard to see with this camera angle, but I have the gap I was looking for under there. And we are all set. And I should mention, the last thing we need to do to prepare this is they want the bottom edge here to be chamfered, and that means to take away the corner, this edge right here. And this was easily done by placing this corner on the Scotch-Brite wheel and knocking it off a bit. You can just about see how I did that. Now we can continue assembling our drive horn. First we'll take T1305, and that will fit underneath the horn, and the pre-drilled holes will match up very nicely with the holes on the horn, and it will fit just like this. And I'll go ahead and Cleco this together. And I'll be using my silver Clecos because those fit the 3/32 holes, our pilot holes. And there we go. Notice it is underneath the horn, this being the top. Our next step is to take T1306, which is this small bent angle, and it is pre-drilled. It has 3 holes in the side and 2 on the bottom. And that will be located right here. And I'll Cleco this in place. This goes on top of our horn. It shares 2 holes in the top of the horn. And finally, T1304, which is this piece here, will also fit on top, and the pre-drilled holes in it will line up nicely and be located right here. And I'll go ahead and Cleco that in place. So we have the 2 on top and the large horn, the large rib on the bottom. Now that leaves 16 holes. Our next job will be to turn this over and drill to our final size, which will be the 1/8 inch holes. I actually like to use the number 30 drill bit. The number 30 is just slightly bigger than the 1/8, and that'll make it easier for the rivets to go in. And we have all 16 holes drilled out to size 30. I am now going to disassemble all of the pieces and deburr all of the holes, both sides. I'm going to then re-Cleco, and then we will rivet using the proper rivet specified in the plans. I use carburetor cleaner, safe on aluminum, to remove these labels. So let it sit for about 10-15 seconds, and they'll come right off. And you can use a cloth to remove any leftover gum. And with all of the parts clecoed back in place after deburring, we can go ahead and rivet. The plans ask us to rivet from the bottom up, so we'll rivet with the heads on this side. We'll use the rivets as called out in the plans, the CCP 44s, and we'll insert them from the bottom. And continue with all 16 holes until we have finished. And here is the finished result. Here we have the rudder skin. This comes as an undrilled, uncut piece of aluminum, and it has a lip down here so we can unfold it a little bit if we need to, especially for cutting. Now our job now is to mark the cutout because we have an angle to make. Now this is described and documented in the plans, and we'll take a look at my lines for cutting out. The cutout for the top versus the bottom, or one side versus the other side, is a little bit different. But again, if we use the dimensions in the plans, we should come up with something very similar to what I've drawn. So I've just used a pen and drawn on the plastic covering. And let's take a closer look at the actual drawing I made for cutting out. Now this is looking at one side. We have the thick part at this end and the thinner part down here. And using the plans, I made a mark at this end and drew it up here, and actually went from the corner all the way to the dimension they gave down here. Now then there's an additional cutout, and in fact my very first step is I need to drill a 1/8 inch hole right here because we don't want any sharp corners. And in fact the plans will call for a 1/16 radius, and if you use a 1/8 inch drill bit you'll get your 1/16 radius. So I'll drill that right here, but we're going to end up cutting this out with our snips and then cutting this out to here, and we'll have our circular radius left because we drilled it. And then on the edge we have a straight line. I'll make that a little darker when I go to cut. And then on the back side, or the other side, it's not really the back, we have a line here, a radius again, and then a cutout. And I got all of the dimensions for drawing this line from the plans. So I'm going to go ahead and drill my 2 holes and commence cutting with my snips. I tend to cut outside the line so that I can come back a second time and make the cut closer to the line. That way it makes it easier to get a nice smooth cut by cutting it twice. Cut it real close the first time and then cut it right on the second time. And there's the hole right here that I drilled. We could also use a file after we're done cutting to round that out, but either way the size of the hole gives us an idea of the radius that is needed. And I'm just going to use my snips to start a cut and work my way around. And then I need to cut out this area here. And also a straight line along the back here. So I just need to keep trimming away. Then our next step is to peel away the white covering and use a file and clean up all the edges, make them nice and smooth, and double check our radius is smooth. Use a round file if necessary, and then we'll be ready for our next step. But here's what one side looks like, and here's what the other side looks like. Depends what angle you look at as far as getting a good picture. Now at the opposite end, we need to draw a line, and this will be a straight cut. So I'll use my tin snips, and this is a straight cut all the way around to the other side. And the length, of course, from one end to here is in the plans. I'll go ahead and cut that and then remove the white wrap.
So if you have made it this far, a great time to get back to building. See you for the next part coming up soon.